Hello, everyone. My name is Vladislav Kaverinskiy. Today I am presenting our research on a unified processing pipeline for automated IMU-based analysis for human resting states. This work was conducted collaboratively by our team at the Kyrylo Institute of Cybernetics and the Chernobyl National Medical University. To understand the relevance of our work, we must look at the current landscape of wearable technology. The application of internal measurement units or IMU sensors is growing rapidly for continuous monitoring. However, if you look at the literature, the vast majority of research is heavily focused on working gait analysis and active behavioral monitoring. Conversely, resting states such as sleep and immobility remain significantly under-researched despite making a massive portion of our daily lives. Therefore, our primary objective was to develop a modular, comprehensive software framework specifically for the automated analysis of human resting states using IMU data. At the core of our solution is a 6-stage software architecture which you can see outlined here. First, we handle data preprocessing, dealing with noise filtering and normalization automatically. Second is feature extraction, where we pull motion descriptors off the data window. Third, we have physiological estimation, analyzing respiratory and heart rate dynamics. Fourth is state classification, categorizing the exact moment state of the subject. Fifth, temporal analysis allows us to isolate micromotions and behavioral segments. And finally, report generation, which automatically creates statistical summaries. By separating this into distinct modules, the pipeline is highly extensible and robust. Moving on to our primary analysis methods, we deliberately designed the system to be interpretable. We don't rely on black box models. Instead, our framework extracts physically interpretable features. We describe moments simply by effectively through energy, jerk, and amplitude. When it comes to classification, rather than using rigid fixed thresholds that might fail on different patients, we leverage adaptive thresholds based on median and interquartile ranges of specific recording. Additionally, the system performs a direct estimation of respiration and heart rate from the inertial data, bypassing the need of secondary cardiovascular sensors. Let's look what this means in practice. Here is an example of moment states classification distribution over a rest period. The system automatically segments the timeline into coherent behavioral states. In this recording, you can see micromotion dominated roughly more than 50%. This is incredibly useful because it reflects the natural resting dynamics. We can automatically detect deep rest periods, isolate micromotions, and identify major terms. Besides detecting moment, our framework also estimates heart rate and respirations. This graph shows heart rate together with moment intensity. We can see that the heart rate often increases before larger body movements during sleep. This demonstrates that IMU data can provide not only information about movement but also useful physiological features. And from the engineering perspective, computational performance is critical for processing massive overnight recordings. We benchmarked the pipeline and focused and found it exhibits strictly linear scalability with dataset size. We also found that the choice of temporal window size has a minimal effect on the overall runtime, and finally, while parallelizing the process across multiple threads accelerates computations initially, the efficiency drops off after a few threads due to synchronization overheads. To briefly conclude, first we have successfully developed a modular automated software framework capable of processing IMU data without manual intervention. Second, it provides a dual analysis classifying major activity while simultaneously estimating vital physiological parameters. Finally, this architecture is highly extensible. It is ready for integration into third-party digital health application, paving the way for future incorporation of machine learning algorithm and rigorous clinical validations. Thank you for your attention. Goodbye.